In this video, we're going to talk about how to do a functional FMEA using SLIKWORKS. To give a little bit of background about functional FMEAs, a lot of companies perform functional FMEAs before they perform system FMEAs and hardware FMEAs. And the way this works is you normally would define a vehicle function and you would create a functional architecture for this vehicle function. Without allocating it to physical components, just how the function should behave without defining the components that are necessary. And then once this functional architecture is available, then an FMEA is performed on this to identify what potential safety mechanisms we need. So this in a nutshell is an FMEA. A lot of companies perform hierarchical FMEAs where there is the highest level is a functional FMEA, and then they do a system FMEA, and then they do a hardware and software FMEA. For now, we're going to take an example of one functional FMEA and see how this can be done in SLIKWORKS. And I want to take a function which is very, very popular in most cars and trucks. It's a stability control function. So let's create a new project in SLIKWORKS. Once we go into this dashboard, it gives you the option to perform an FMEA and an FMEDA. You just want to choose the FMEA. We're going to choose a custom template over here. This is something that we perform specifically for the functional FMEA. We're going to choose this template. So we're going to upload an architecture diagram. We're going to choose an architecture diagram which is very specific to the functional FMEA, and in a bit I'm going to show you what the diagram is. If I open the architecture diagram, this is what it looks like. There's many ways of creating the functional architecture. This is a way of doing it. So for the stability control function, essentially what we're doing is we're determining the driver requested driving curvature. Driver wants to go in a curve, and then we're determining what is that curve. And then we're determining what is the actual curvature based on sensors around the vehicle. Intentionally, we're not talking about what the curve here means. Is it based on yaw rate, lateral acceleration, or steering angle, or what it is we're not defining. We do a comparison between the requested and actual curvature. This helps us identify whether we are oversteering or understeering. And if we decide that we are either oversteering or understeering, then we can modify the forces at one of the wheels. We're assuming 4 wheels over here, which is on a car. And you can modify the forces based on applying brakes. It could also be based on modifying the torque to the engine / motor. It could also be through electronic limited slip differential if that is available. It's also possible to do this through air suspension if the vehicle is equipped with it. So there's a combination of things that can be done to just modify the lateral, longitudinal, and normal forces. So here we're not going to define how it's being done. We're just going to define that we're just modifying the type of force. We're modifying the type of the front wheel, the front right, the rear left, and the rear right. So this, in a sense, is the architecture diagram. And you can see these are all functional blocks which are communicating with each other through some signals here. Now that we uploaded the architecture diagram, we're going to use AI to extract components. And the AI part over here is we're using image recognition algorithms to scan this architecture diagram. It sees what are all the blocks and what is the input and output to each block. So that's where the AI part is coming in. Uh, and once you see this, you can see what the actual components are. So it's identified 7 components. 1, 2, 3, 4, 5, 6, 7. So those 7 components, and it's identified these 7 components. Number 1 is compare requested architect, compare requested curvature and actual curvature. Then the second component is determine actual driving curvature, which is the equivalent of this block. Determine driver requested driving curvature, which is the equivalent of this block. Let's take a look at these 2 blocks quickly and see what the tool can do now. So if you look at request driving architecture and you go to edit component, it's identified it as a function. And what it also does is it gives it a 3 to 4 word description of what the function does. In this case, it might be as simple as, it might be the same thing. So here it is determine driver requested curvature. Now here is the interesting part. So SLIKWORKS allows us to perform a hazard, where we combine a function with certain malfunction guidewords, and then we come up with failure modes. I'm going to choose here a few malfunctions. So knowing that the function is determine driver requested curvature, I'm going to say no not. So another way of saying this, not determine driver requested curvature. Then I'm going to add more, and then I'm going to add less. So it determines too high driving curvature or too low driving curvature. Then it also has identifies the IOs to this block. So you see this is the leftmost block, so there is no input. This block has no input. It has one output, which is requested curvature, and that's what is identified over here. So we save this. Now similarly, we're going to take another element, which is determine actual driving curvature. We are going to try to modify this. Here we say the function name is determine actual driving curvature, malfunction. It does not. It identifies that too much, and it identifies less to less. I'm going to save this. For now, we're not going to focus on the rest of the elements. In principle, because it's a functional FMEA, you can do the same thing for each of these elements. For simplicity's sake, let's just take these 2 elements. Then we go to FX. At FX tab, what we're going to do now is we've already performed a HARA, and we can upload all the hazards that are coming from the HARA for this function. There's 2 options. You can either add it manually, then you can, option 2 is upload an image. Option 3, what we still haven't worked on, is there will be a HARA feature available where you can start linking the hazards from this HARA to the FMEA, but this is work in progress. So I'm going to choose this upload image. I'm going to make it easy. I'm going to upload the hazards. Similarly, safety measures. There's 2 options. You can manually add it, upload from an image, and there's a third option we're working on, which is combining it to getting all this information from a database, like a requirements management database. For now, we're going to choose the upload image option, and we're going to get the safety mechanisms. So you can see that it's identified 2 effects. There is the unintended vehicle yaw. And you can see what the description of this. It describes a scenario where the vehicle yaw exceeds the request. The actual vehicle yaw exceeds the request. This is similar to an oversteer situation. You just leave the lane, collide with an object outside. Similarly, there is a loss of vehicle yaw, whereas the driver is requesting a certain curvature. The vehicle is not doing it for whatever reason. So instead of making the curve, you just go straight. You still leave the lane. You're going to collide with someone, an object, or another car. We've taken considered three safety measures. Safety measure one is to plausibilize driver requested curvature. Safety measure two is to plausibilize the road curvature calculation. And safety measure three is check if the actual force of the wheels match the force request. And let's assume for a moment this is coming from the functional safety concept. And we're doing the functional FMEA to check if the functional safety concept is complete. Now that we have this, we can go ahead and we can start generating the form sheet. So I'm going to click generate form sheet. It's going to take a couple of seconds to generate the form sheet based on all the information provided.